Rita Das to just introduce the speaker today, Sheila, and a little bit about what we are doing today.
Okay, shall I start?
Yeah, please.
Good evening, everyone. I am Arpita Das, PhD scholar from IIT Guwahati. I welcome you all to the fifth session of Research Learning Circle. We have with us Miss Sila Mishra as today's speaker on data envelopment analysis. Let me give a brief introduction about her. Miss Sila Mishra is a research scholar in the Department of Economic Sciences at IIT Kanpur. Her area of interest primarily lies in applied microeconomics and the economics of family and gender. As part of her research work, she has explored the efficiency of Indian banking sector, network readiness of countries, and technical efficiency of Indian judiciary. She is currently exploring India's time use survey. Thank you for joining us. We would love to hear from you. Over to you, Ms. Mishra.
Hello, thank you, Arpita. And yeah, so I'd like to share the screen. Just a moment. I hope it's visible. Hello, hello.
No, it's not yet. It's not yet visible. So
Is it now?
yeah, it's
Hello.
Yeah,
now
it's
yeah,
visible.
it's
Yeah.
visible.
Fair enough.
Yeah.
So before delving into this talk, I would like to make it very clear that it would be an interactive session in the sense that I won't be delving much into the technicalities or more of the methodological point of view, but I'll still try to give a bird's eye view of what data envelopment analysis is and how we can apply this methodology. So now, before going ahead, I'd like to understand that since many of the students in the lot are from economics, so one can assume that one can understand that what a production unit is. So a production unit uses some amount of input to produce some amounts of output, right? So these production unit in our these production unit would be termed as decision making unit because they do make decision in terms of what amount of input they need to use to produce the output. So for some decision making units, they might be producing one output, and some might be producing more than one output. So and as far as the example of production units are concerned, we are aware of uh, some examples like banks, even the courts, the insurance companies, the railway zones, airports, hospitals, and educational institutes. Now, so what does efficiency mean for a production unit, and how do we compare the production units? So, if we take the example of a bank, so there are so many branches of State Bank of India, right, in Indian context, and one might be interested in understanding how do each and every branch of State Bank of India performs, and how can we compare all these branches of State Bank of India. So and moreover, how do we do it? How do we estimate the efficiency and compare these decision making units? So so by efficiency in economics, we have two terms. One is technical efficiency, and the other is the allocative efficiency, right? So, by technical efficiency, we understand it is basically the rate of processing of inputs or outputs, and in the it can also be termed as the ability to maximize output given the level of inputs. Now, why efficiency is important? It is important because it can help the policymakers in informed policy decision making, and also by optimizing resource allocations. So how do we estimate the efficiency frontier? So there are two methods by which efficiency frontier could be estimated. One is a non-parametric technique, and the other is the parametric technique. And in non-parametric technique, we have data envelopment analysis, and parametric technique we have stochastic frontier analysis. So regression. So what do we mean by parametric and non-parametric technique? So when we consider the kind of the methodology that we as economists might have come across is the regression analysis, right? So regression analysis is a kind of parametric technique wherein we, based on the dependent and the independent variable, we get the value of alpha coefficient, we get the value of alpha and the beta coefficients, right? So these are the parameters. So whenever we would be interested in finding these parameters, they would be called, the methodology would be called parametric. And when we are not interested in finding the parameters, then it would be termed as non-parametric technique. And data envelopment analysis is a non-parametric technique. So we neither would be needing any functional form which is required in any parametric technique, and we can deal with other stuffs in data envelopment analysis. So with this background in mind, the agenda for today's talk is to understand a very powerful tool which is used vastly in economics, and it basically helps us in measuring the relative efficiency of decision making units. So as I mentioned in the first slide also, that decision making units are nothing but the production units, which could be anything, like which could be a firm, which could be banks, which could be railway zones, which and among others. The second agenda of this talk is to apply data envelopment analysis in in a special context of high courts. So I'll be applying data envelopment analysis to estimate the efficiency of high courts in India. So the data is available for 24 high courts in our study, and how do we understand the mechanism of this methodology? So this talk would delve into first investigating what DEA is, and then applying DEA to a special context of in the special context of high courts in India. Now, what is a data envelopment analysis? So data envelopment analysis, as I mentioned, is a non-parametric technique. We are not interested in estimating any of the coefficients that I mentioned. However, it helps us in estimating the relative efficiency. So we are always interested, right? How 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 one educational institute is performing as compared to the other educational institute, right? So how can we compare all the IITs in India, or how can we compare all the IIMs in India, or even how can we compare the hospitals in India? It could be primary healthcare center, community healthcare center. So how can we compare? So when we talk about DEA, it gives us a relative efficiency measure. So we would not be talking in terms of absolute efficiency, but we'll be talking in terms of relative efficiency, right? The other thing about data envelopment analysis is that it does not require any predefined functional form of production function. So what do I mean by a predefined functional form? It could be a Cobb Douglas or CES. We don't need any such production functional form when we talk about data envelopment analysis. So it's quite flexible in its methodology. Moreover, it can deal with multiple inputs and outputs simultaneously. So one thing you might be intrigued that, yeah, data envelopment analysis, I can also perform this similar analysis in regression, right? We have some inputs and we have one output, right? However, how data envelopment analysis is different from any of these methodologies in the sense that it takes care of multiple outputs. So here is an example of insurance sector, which uses these amount of outputs, and it produces two kinds of output. One is the net premium written off by insurance company, and the other is the net income. And the
Hello.
insurance company primarily uses hello.
Yeah. Sorry, I disturbed, but your voice broke a little. So can you just repeat a few lines that you said,
Yeah,
especially
fair
after?
enough. So
Yeah.
functional form, was it clear till relative efficiency production function form?
Yeah. Yeah. It was.
Fair
It
enough.
was
I'll
okay.
just
Yeah.
repeat it. I'll just repeat it. Yeah,
Yeah.
it's
Yeah.
okay.
Mm.
So data envelopment analysis is a non-parametric technique, and it helps us in estimating relative efficiency, right? So we won't be when we talk about about a particular setup of banks, and we talk about the efficiency of those banks. and span. So here we would be comparing all these banks among themselves. So there won't be any outsider bank uh, uh, which would be considered as a benchmark, and we would be comparing on the basis of the same. So we would just pick the comparison would be in the same lot where the data would be obtained from. Now, the other distinct feature of data envelopment analysis is that it does not require it doesn't require any functional form or production function. So in economics, we do talk about that there are several kinds of functional form, right? One is a Cobb-Douglas function form, and the other is a CES, and there could be other functional form as well. So data environment analysis does not require any such predefined production. In regression, we can only examine the association between independent variables and dependent variable, right? And but in data envelopment analysis, we can estimate the efficiency of decision making units by having more than one output, and of course more than one input. So taking the example of insurance company here, we can see that an insurance company in the Canadian context uses these many inputs, which are labor expenses, general operating expenses that it incurs, moreover, the outputs in capital equity that it possesses in insurance company context would be the net premium written off by these insurance companies and the net income of the Canadian insurance company. Now, this is what makes data environment analysis unique, that it is a non-parametric technique and it can take care of multiple inputs and multiple outputs. Now, moving further, now how does it function? So on the y-axis we have one output, and on the x-axis we just have one input. So it's a simplistic form which I'm trying to explain it via graph. So what it does is that we have four decision making units. You can assume that these are the four branches of State Bank of India. Let's say in Uttar Pradesh. Now, DMU1 and DMU3, which are lying on the efficient frontier, could be State Bank of India in Lucknow and State Bank of India in Kanpur. So these are the two DMUs lying on the efficient frontier. And the other DMUs, which are let's say one in Gorakhpur and the other in Varanasi, which are DMU4 and DMU2, are the inefficient one because they are lying below the efficient frontier. Now, how can Gorakhpur how can the State Bank of India of Varanasi and State Bank of India in Gorakhpur could be made efficient? So it could be made in two ways, right? One could be that, let's say if you're at DMU4, which is inefficient, then you can reach the efficient frontier by either maximizing its output, right? Or by minimizing its input. So whenever we would have output maximization technique, then the output would be maximized given the level of inputs. So when we are going vertically from DMU4 to the efficient frontier, there won't be any change in the input. However, we would just be intending to maximize the level of output. Moreover, when we would be at DMU2, if we are interested in just minimizing the inputs, that is, if the bank is just interested in laying off its employees or even cutting off its expenditure by keeping the output level fixed, which could be the loan disbursed by these banks, then it can just minimize the output by keeping the level of outputs fixed. So this would be the input minimization technique. So data development analysis, it's very important to understand what your objective is. So in case of banks, one would be interested in maximizing output, or one would also be interested in minimizing the input. Based on the literature review and your objective at hand, you can determine what kind of technique that you are that you want to investigate. Further, what is the mathematical formulation of data and weapon analysis? Now, a data and weapon analysis uh, has a very integral relationship with the linear programming problem, which we might have studied in class 12. I'd still like to elaborate on the same. So, it's a kind of linear programming problem wherein if we intend to maximize the output, then our objective function would be maximize the weighted sum of output maximize the ratio of weighted sum of output to the weighted sum of inputs, which is also evident from the numerator and the denominator. So we intend to maximize the maximize this ratio given the constraint of all the other DMUs. So if I want to get the technical efficiency score of, let's say the State Bank of India in Varanasi, so I'd be in the maximization function, I would be I would just keeping the ratio of the weighted sum of weighted sum of their output to the weighted sum of the input. Whereas in the constraint function, I would have I would have the efficiency of all the banks in the comparison. So I would also have Bank of Varanasi, Bank of Gorakhpur, Bank of Kanpur and Lucknow, which I mentioned in the previous slide. So what we primarily do in DA is that if we are talking about output maximization, then we would be maximizing the weighted average of output, the ratio of the weighted average of output with respect to the weighted average of input, subject to the same ratio of all the TMUs that are present in the analysis, and which would be less than equals to 1. Now there are two kinds of model that are there in DEA. So based on the returns to scale assumption, we know that there are one is the constant returns to scale and the other is the variable returns to scale, right? So the first model, which is a CCR model, is based on CRS assumption, which is a very rigid form of assumption. And the BCC model is for the variable returns to scale assumption, which takes care of both increasing returns to scale and the decreasing returns to scale. Now, how does one identify that where my decision making unit falls? So if So as I mentioned, that the rate at which my input would increase, the rate at which my the rate at which I'm increasing my input, the output would also increase at the same rate, which is a very strong assumption, right? So CRS becomes a very rigid assumption, and which is why there are very less studies which investigate technical efficiency through this route of CRS. However, majority of the studies in DA context take consider variable returns to scale, so which is a very flexible which is quite flexible in the sense that it takes care of both increasing returns to scale and decreasing returns to scale. Now if you have carefully noticed these CCR and the BCC model, CCR is for constant returns to scale and BCC for the variable returns to scale, you might have observed that the objective function and the constraint function are the same. However, in the BCC model, we have an additional assumption of convexity constraint, which is nothing but the the sum of lambdas is equals to 1, which is nothing but the weights are free in BCC model, as in both IRS and DRS are taken care of in BCC model, or the model wherein we are considering variable returns to scale. Now, this is a case of output maximization where our main goal is to maximize the output, right? However, when we talk about the input minimization technique, there the objective function might reverse. In the previous model, we were maximizing the ratio of output to input, right? However, when we would be talking about the input minimization technique, you would have noticed that in both the CCR and the BCC model, the objective function is to minimize the ratio of weighted sum of inputs to weighted sum of outputs. However, the core of both these methodologies remain the same, as in that in the objective function, we would have one bank, and we would be maximizing one bank efficiency with respect to all the banks' efficiency, right? Now, moreover, moving on to the efficiency measures in both these models, so there are three kinds of efficiency measures that you would get. One is the technical efficiency in case of CRS. One in the case of VRS, variable returns to scale, and the other that you would get is the scale efficiency, which is nothing but the ratio of technical efficiency obtained from CRS divided by technical efficiency from VRS. Now, moreover, how is CCR model different from BCC model? So as I mentioned in the previous slide, the CCR model, which is nothing but which is a methodology given by Carnes, Cooper, and Rhodes, assumes a constant returns to scale. Assumes constant returns to scale, as in that if the inputs are increased at 1% unit, then the output would also increase at the same percentage. However, since it's a very rigid assumption, Banker, Kans, and Cooper developed a model which takes care of big VRS, which means that the decision making units can operate at different scales, as in they can also operate at increasing returns to scale and also at decreasing returns to scale. And in the linear programming problem also, I mentioned that the basic difference between CCR and BCC model is in the sense that there is an additional constraint in the BCC model, which was a convexity constraint, as in the summation of lambda I was equals to 1. That takes care of both IRS and DRS. Now, moving on to the steps in conducting data envelopment analysis. Now, so these were the technicalities of data envelopment analysis. Now, how do we perform data envelopment analysis? Now, the first thing is that you need to define what a decision-making unit is. So, if you are interested in, let's say, estimating the efficiency of railway zones in India, so there are various zones of railways in India, right? So, all these zones would be considered as a decision-making units, right? And all these decision-making units would be consuming some amount of inputs to produce some amount of outputs. Now, these inputs could be in the form of labor, the expenditure that these railways incur on them, and the output could be the passenger freight, or even the cargo freight cargo revenue. So this is the first thing that one needs to do in performing data analysis. Another thing that one needs to make sure is that your both input and the output variable should be continuous, in the sense that we cannot consider dummy variable in input and output variables. Moreover, after that, we obtain the efficiency score by solving the linear programming problem, as I mentioned in the previous slides. The software that I'll be talking about in the subsequent slide would take care of that linear programming problem. So you won't have to calculate the efficiency scores by solving the LPP. That would be taken care of by the DEP software. After that, once you are done with decision making units and the inputs and the output that you intend to have in your model, the DAP or any software would give you efficiency scores. Now, efficiency scores primarily lies below 1 or equals to 1. So, any decision making unit which has a score of 1 would be considered as it is the efficiency. All the other decision making units which have a score below 1 would be considered inefficient. It is very important to also take a note of the fact that there might be a case that there will be more than one decision making unit that might have an efficiency score of 1. So in that case, both any amount of decision making units which have an efficiency score of 1 would be termed as benchmark or technically efficient decision making units, and the other decision making units that have an efficiency score of 1 would be considered as inefficient. And another interesting thing to note is that whenever we would be interpreting the results of these efficiency score, we would always write that the results are in comparison to the benchmark decision making units. And by benchmark, what I mean is that the decision making units with the technical efficiency score of 1. Now, moving further, uh, so where can DA be applied in economics? So there are various journals which cater to these methodologies like analysis or even stochastic front-end analysis, and the papers that have delved into them. This is not an exhaustive list of application of DE in economics. However, these are the areas. So. Uh, DE has been applied in the manufacturing sector, banking sector, insurance, airport, and healthcare sector. So, they can also be applied in the case of public sector evaluation. Like one can also compare the schools of a particular state. One can also compare the railway lines, railway zones, and how the local governments are performing, and even the courts, even the judicial institutions. Moreover, DA has also been applied in the context of environment sustainability studies because DA the DA that I'm talking about doesn't take care of bad output case. So there are various methodologies related to DA which takes care of bad output like pollution. So there are studies that have used DA to also perform environment sustainability studies. Moreover, it has also been used to analyze the efficiency of innovation and technology. Now, moving further, so uh, based on the discussion so far, there are various advantages and disadvantages, limitations of data environment analysis. So the advantages of DEA lies in the fact that it can take care of multiple inputs and output. Number one, number two, that it is non-parametric in nature, as in we don't need any functional form to perform DEA, right? The limitations of data environment analysis is the sensitivity to outliers. So, for example, if you're comparing um, if you're comparing a village with the village level, if you're comparing the panchayati raj institutions in a village to a very small village to a panchayati raj institution in a very large village with a lot of infrastructure, then that might lead to the problem of outliers, right? So one needs to take care of that. Moreover, it is very important to carefully select the inputs and output in the analysis. And the third is how to since in regression also we have to take care of we have to take care of degrees of freedom. In data development analysis also we have to take care of degrees of freedom. So by degrees of freedom, what I mean is that if n is the number of decision making units. So for example, as I mentioned in the previous slides, that if we have four banks, four State Bank of India branch in Varanasi, Lucknow, Gorakhpur, and Kanpur, then there are four decision making units, right? N would be four, and M would be the number of inputs that we would be considering for the analysis. S would be the number of output. So, so in the case of banks, the inputs would be, let's say, number of employees in the bank, the amount of deposits that the bank has, and the expenditure allocated by the expenditure incurred by the bank. So these there are three inputs, right, in the system. So the product of one into three is three, and these three inputs would be caused by these banks. So moreover, we have one output and three inputs. So the product of one and three is three, and if we consider the sum of m plus if we consider m plus s, then we have 3 plus 1 4 into 3. So our decision making unit should be more than the maximum of these two terms which are there in the bracket. So please take care of the degrees of freedom in that case. Now, so I'd like to stop here for a while if you have any doubt so far. So yeah, I'll move on to the subsequent slides. Do you have any question here till here? Yeah,
Hello.
yeah.
So, what I understood is whatever, like for example, in case of banks, if we are considering 15 banks, so among them it
Mhm.
will choose one bank which is the most efficient one, that is which ranges till 1, which has the score 1. So, based on that, it will compare other banks, is it?
Hmm. So you're partially correct, and so what happens in DA is that you have the data of 15 banks, right, with you, and each bank would be using some amount of input to produce output. So based on the inputs and output that these bank would be using and producing output using the input, it would get the efficiency score of each and every bank, right? And then whichever bank would have one as technical efficiency score would be considered as a benchmark and would be considered as technically efficient, and the other banks which have technical efficiency score below one would be considered technically inefficient. So this is how we do. So yeah,
Okay, based
still,
on that technical efficiency which the bank got 1, so other numbers will be assigned to other
yeah,
banks. Okay.
Mm-hmm.
So, like,
So,
is it so in line to what she is asking? So, what I was
mm,
also say, so is it like sort of compulsorily happening this way, that if I have say data for some number of firms, or say maybe some number of banks, as she said, so there will be
mhm.
mandatorily one firm out of those 15 for which we will get the score 1. Is it always there?
Right, right. Always, always,
And
always.
it's like it's obvious, in that way it's obvious also, right, that if we get say some
Mm.
scores, say one I got 1.5 and another I got 1.7, so it implies that 1.7 is more efficient than 1.5, right?
Yeah, yeah. That's there. However, one thing which is interesting is that technical efficiency score would always be less than equals to one, so it cannot go beyond one.
Right.
Yeah. So it would be like, for example, if State Bank of India in Varanasi has a technical efficiency score of one, and the other banks have efficiency score of like point 0.4, point 0.6, then these are totally comparable, right? So I
Yeah.
would say that if State Bank of India in Lucknow has an efficiency score of point 0.4, then it would be less than that, right? And it is technically
Hmm.
inefficient. I mean, it has a huge potential to minimize its input to go to the efficiency frontier, which is of course the State Bank of Varanasi, or it
Yes.
can also maximize its output to reach to that efficiency frontier. So it can go in both the ways, by increasing the output or by decreasing the input, right? So yeah.
Yeah, like we, yeah, that is there, that is there, right?
Mm.
So now you will be showing this how to implement this thing in a, DAP, right?
Right, right. So
Okay.
So now in this context, I'm just focusing on the efficiency of high courts in India. So based on the data available so far, we have just 24 high courts in India. So what I mean by 24 high courts is that there are high courts in two other states. However, the data on both of them were not available for the year that we had considered. So the decision making units in our current context would be the high courts in India, and there are 24 decision making units. Okay? The outputs in the current context would be the cases disposed of by the courts. Okay? And the inputs that these courts use are caseloads. What are the number of pending cases in these courts, the number of judges, the number of judicial staff, and the expenditure allocated. So you might have noticed that these numbers, some of them are in the absolute number, some of them are in the form of rupees. So decision DEA takes care of the unit, right? So you can so as far as the variables are continuous, you need not worry about the scale or the unit of these variables. Now, in our context, as I mentioned, that we need to decide upon two things. First is the orientation of the decision making units, DEA, right? So in our context, we would be using output-oriented data envelopment analysis instead of input-oriented, because from the literature reviewed so far, we could fathom that um, the objective of the courts should be to maximize the cases disposed of. So the decision of what the orientation should be was based on the literature reviewed. So here we are using output-oriented data envelopment analysis. Moreover, as I mentioned in the previous slides also, the other thing that we need to take care of was the returns to scale assumption, I mean CCR or the BCC, right? So since CCR is a very rigid assumption of constant returns to scale, we would be primarily having VRS, as in BCC, variables returns to scale. So because we assume that courts might experience increasing returns to scale and decreasing returns to scale. Now, here is the data. So, data for the data of these codes for the year 2015-16, and as you might have noticed that in the first column we have the decision making units. In the second column, we should have the output followed by the inputs, right? Now, here is a link to the DAP software. I would be sharing um, I'd be sharing the software. I'd be sharing these slides with you so that you can access the software. So this will take you to this page. It's a university. It's the software was developed by University of Queensland. At the bottom, you would get this software link, download software, and from there you can download this software. Now it's a kind of zip file which would which you need to extract. So,
Sila,
yeah,
I would like to interrupt. This already I have sent in the group. I hope everyone
ठीक है.
has downloaded it. So we will not waste time here. You can start from your
Fair
end.
enough.
Yeah,
Fair enough.
thank you.
So, so here is the Excel file of the data that we had. The first thing that you need to do is to whenever you would be preparing the data for DEAP, it's important to not have any text in the file. So I've replaced all the name of the codes with the numbers. So here we have 24 high codes mentioned with numbers. The first column after that is the cases disposed of, which was the output followed by the input. So in this case, we have just one output and four input. Okay. Now, so going back to this software, so this was a zip file, and you might have extracted the file, I suppose. Now, uh, you can pick up any data file or the output file. So here we have EG1 DTA, and I have already pasted my data set, which looks like this. So in the first column, I have all the decision making units, which are not in the form of text, followed by the followed by the output column, and then input columns. Now, as I mentioned, that there are 24 decision making units, one output variable, and four input variables. I'll just close this data file. Now, I'll just look at the instruct. So here is the instruction file, EG1 INS. Now, the first thing that you need to do is that it's a case sensitive file. So you need to make sure that a file follows the case by which it was saved in your system. So I have already edited the data. So it looks like this. You just have to edit these things. The one on the left hand side. So the right hand side elements would be there. You just need to edit the left hand side elements. So in the first row, the data file name is eg1dta.txt. Output file, as I mentioned, was eg1, which is also there here. eg1 dash output out. Number of firms in our case are 24. Since we have only one time period analysis, so it's 2015-16, it's one. Number of output in our case is just one, followed by number of inputs, which is four. Since I mentioned that I'd be only focusing on output oriented DEA, it is so if you are using input oriented DEA, I mean, if your aim is to minimize the output, given the output, then you would be using zero here as code. So, and if your objective is to maximize the output given the level of input, you would be using one as a code here. So which is already written as one here. Now, based on the based on the returns to scale assumption, we have two things. One is CRS and the other one is VRS. So, as I mentioned, that CRS is a very rigid assumption, and we assume that codes might experience increasing returns to scale and decreasing returns to scale. So VRS takes care of both of them. So I'll be using one as a code here. Now, so since it's the first session on data envelopment analysis, I have just explained data envelopment analysis. So here I've just explained to you what is the first stage data envelopment analysis. So here the methodology that you would be using here is just just the code number 3, and since it's the first stage day. Now I'll just save this file, and then I'll move on to this program file, which is DEAP, which is this is a program file. Here, what you would do is, I hope it's visible, right? So you just press enter to enter the name of the instruction file. Be careful with the name of the instruction file because it's case sensitive. So my instruction file has capital E, small g, 1 dash ins.txt. Press enter, and then it would save. Please make sure that all these files are updating as per the time at which you might have modified. So I modified my instruction file, and before the meeting, so it shows the time. So now my output would be stored in EG1 dash output. So the results are shown like this. I have not edited any of this. It is the results are based on the linear programming problem that it might have solved. Now we just have to focus on three things. So as I mentioned, that my data file was eg1-data.txt. Output orientation, I have used output oriented DEA. The skill that I have assumed was VRS, and I've used single stage data analysis. Now, these are the firms. So, decision making units in this software are termed as firms, which are 24 in number. Now, first column after the firm shows constant terms to scale technical efficiency, VRST, and then scale efficiency. So, you can notice that since we had assumed VRS, so there are all the bank's experience decreasing returns to scale. Now, since Shivam had a question, Shivam said that it is a necessary thing to have at least one decision making unit to have one as technical efficiency score, which is there. So, if you look at the variable VRS technical efficiency score, you might have observed that um, DMU number 23, 20, 22, 23, and 24 have a technical efficiency score of 1, which means that these codes are technically efficient. However, the other codes are technically inefficient, and also code number 17. So these codes are the benchmark. So code number 17, high code number 17, high code number 22, 23, and 24 are technically efficient codes, which would be also termed as benchmark codes, on the basis of which we'll be comparing other codes. And the other codes are technically inefficient because they have a technical efficiency score of below 1. So how do we, and on average, as we can see that the technical efficiency scores of all the high codes combined, it's just 0.540, which is which is half. Now, moreover, so how do we interpret these results? Um, now, see, so as I mentioned in the previous slides and in the by using the software also, that efficient units have a technical efficiency score of 1, while the inefficient units have efficiency scores below 1. And whichever decision making unit has an efficiency score of 1 would be termed as benchmark, or the efficient, or the one which makes the efficient frontier, and the others would be inefficient, and we'll be comparing the other codes with the benchmark codes. And moreover, so so based on the analysis so far, if anyone has any question, do let me know. um, the software, or even the methodology part, or even the utility of this methodology, or the limitations of the same. If you have any question, do let me know. I believe.
Yeah,
Hello,
hello.
Yeah.
Sheila.
Yeah.
Hmm.
Hello, Shivam.
I think somebody else also has a question, or
Gurvinder
yeah,
here.
yeah, Good Vinderji.
Sheila, I think in this Frontier 4.1, there is some limitation on like how many DMUs you can take in DE. So, is there any restriction in this software as well? Like for
So,
analysis, how many maximum DMU we can take in this software?
Hmm. So this DAP software, in the manual of DAP, it does not write the limitation. It does not write about the number of DMUs which can be examined.
Okay.
However, I have used 120 decision making units in DAP software. So that's there. Okay.
Okay. So one more thing, can you please repeat that analysis part? How we import the instruction file in DAP?
So so as I mentioned that when you download this software, you get all these files. Okay?
Hmm.
Now, so here is a EG1 instruction file, and you have to answer to all the questions. So if
It is
um,
clear. It is clear. I am asking how we will import this file into the software. After opening the software, what instruction will we will give to the software?
so so here is a programming file,
Hmm.
and just press enter there, and just mention the name of the file with the extension. So in our case it was eg1-ins.txt, and let me check. Yeah, correct. So I'll just press enter and it will process, and the updated result would be there in the output file. So you can see that the updated time is 17:23, which is the current time. So it has
Hmm.
updated the output file.
Okay.
So
Okay.
yeah,
Thank you.
thank you, Gurvinder.
So like every session that we have to say do a different say code on DEA, then we have to fill in the form and fill in this instruction file separately, right, every time.
Right, right.
And so this file, it will be there in the package itself, the package
Yeah.
itself of the when you download this, um,
Mm,
right. So
right,
this software is especially for DEA technique, is it?
right. DA.
Okay, okay.
DA, and since uh, so in today's session, I just mentioned about the cross-sectional setup, right? I didn't talk about panel setup. So in DAP, you can also perform a panel form of DA, and should be termed as Malquest. And there, the time period would change from one to whatever time period you have in a case. So this takes care of all these things.
So there we get the efficiency scores based on
Hmm.
time also.
Right, right. So for each time period, we will have separate technical efficiency scores, and then we can compare ki, DMU 4, DMU 24 has a score of, let's say, point 0.4 in 2015,
Hmm.
point 0.5 in 2016, so on and so forth, and then we can plot a graph based on that. Yeah.
Right. It's not necessary that the High Court, which is efficient in 2014 or 2015, is efficient in maybe 2023, isn't
Right,
it?
right, right. It won't be the case. It might not be the case.
Yeah. It might not be the case.
It might not be the case.
Does anyone else have any other questions? If yes, please ask. Otherwise, we will just like wind up the things. If I think as we are done with the today's material.
Hi,
Okay.
Shiva.
By the time,
I
uh, anybody has question?
Yeah, I have
Yes,
one
Yeah,
yes, yes.
quick
Gurvan.
Please,
one.
please.
So,
Yeah, yeah.
what other type of analysis we can do in this software, like for cross-sectional data, then for panel data, then there are different type of analysis like meta frontier or
mm,
indexes we can find with this software.
mm.
So, what are the names of other type of analysis which we can do in this like software?
So, based on the technical efficiency scores that you might have obtained from this methodology, you can also perform regression. So, once you have obtained the technical efficiency scores of, let's say, all the high codes, then you can regress it over all the independent variables to see how do each and every independent variable is impacting the efficiency score. So, in addition to this, you can also perform cost DA. You can also perform Manquist productivity. You can also get Manquist productivity indicators, and there are other techniques like radial measures, and so on. Yeah.
Okay, okay, thank you.
Thank you, Pupinder.
Seems like we have to come up with another maybe a session or a half of like exploring different angles of this particular software, isn't it?
Mm. Yeah, I'll share the slides.
Yes. In fact, I would like just I would here just like to mention to all the participants that we have uploaded the previous week's previous week's presentation on our YouTube channel. Jawahar has just shared the link of that YouTube channel uh, in the yeah. So in the chat box he has shared this YouTube link, and then plus so to this session along with the its slides, and maybe if allowed, maybe a little bit of data for practicing, and these things we will provide in the description of that video itself. So I assume that there are no more questions. If anybody
Manish
has,
has.
Manish has some
Um,
comment, right? Yeah.
Manish ji, you can
Hello,
yeah.
am I
Hi,
audible?
Manish.
Yeah,
Yeah,
yeah, yes.
you're
I was asking, like, is it possible to compare the units, production units across time using this method or this technique?
So you're talking about State Bank in Varanasi being compared over
Yeah,
time.
suppose there are two branches and we want to compare them across a particular time period, maybe 5 or 10 years, or
So
compare the same branch with itself, like uh, how it was
over the
5 years
years, I
back
get
and
it.
now.
Hmm. Hmm.
Mm.
So, in that case, the degrees of freedom assumption would get violated. However, you can still estimate the technical efficiency using the linear programming problem, which would be easier to estimate. And you can contact me if you want to do it manually or using linear programming problem. So, as I mentioned, that one needs to take care of degrees of freedom here as well, in DEA. So, in your case, the decision-making units are just two, and the inputs and output might be more than number of decision-making units that might get violated, and it would be difficult to use DA there. However, you can still estimate technical efficiency using the traditional techniques of even just weighted sum of output to weighted sum of inputs. This is how one can estimate technical efficiencies for. Yeah.
Okay, fine. Thank you.
one more thing. I just wanted to request the participants in this meeting who have joined very newly. Kindly share your phone number so that we can add you in the group, and you can get the regular notifications of the upcoming lectures also. So kindly do that. And as Shivam was talking about the YouTube link also, that YouTube link we have provided for the last sessions. So kindly you can access those lectures, and these lectures also we will be uploading it, and we will provide for you. So on the same channel it will be there. Okay, Shivam.
Thank you for the comment, Manish.
We will be welcoming the feedback from the other member also. If they have any feedback or any questions, kindly raise your questions, and you can provide your feedback also, so that it will be give a
Sure.
motivation to the speaker for the next sessions.
Thank you.
Gurvinder is saying thank you. Anybody else have any questions or any suggestions, feedback? Kindly let us know. We will work on it. We will improve ourselves in that area. And as well as we will request all the members also to kindly be present for the upcoming sessions also. It will be motivation for us. I think okay, everyone is saying thank you to Sila Mishra in the chat box. So formally I would like to invite Shivam Chogole to propose a vote of thanks to Sila Mishra. Shivam Chogole.
Hello. Yeah. So Sheila, as you can just feel from the chat box itself that people are actually quite happy with the session today. And it was indeed a quite interesting thing to know, like how we can use this data involvement analysis for measuring the efficiency of the the decision making units, as you are as you said. So like this is an integral part of a research, in a way that we need to find out the ways to compare certain things, um, and like derive the conclusions about how the things are operating in a way. So data envelopment analysis, as you explained, proves quite a good method for that. Next week you will be talking about this stochastic frontier analysis. There we will see the parametric approach to the similar problem. But yeah, today's session was quite an interacting and interesting. People actually posed different questions, and like you are quite thorough to your and to your answers. And uh, it I hope that it proves useful for most of us here, um, uh, especially like all the members can reach to us in order to get any more clarification if required regarding these topics. Plus you can always go through the video lecture that we may be uploading in the YouTube channel, in order to in order to get clarified more and more about this technique. And I would really like to thank Sheila for this entire effort of hers, because I just could see how much detailed in the analysis, how much detail she went into it. In a stipulated time, she tried to cover as many things as she can, in order to make a layman understand what the data envelopment analysis is all about. So that's a compliment for you. That's a nice job that might prove useful for all. Thank you very much. And I would especially like to thank you for another thing, that you are actually encouraging the those who are actually willing to participate and like maybe present some of their topics of interest. It would be a useful like people coming up to present their things here, um, as we are providing the platform for all of us. So thank you very much in this regard, and thank you very much for this session. Please look into the next. We are looking forward for the next week's program, where we might be doing this stochastic frontier analysis, and continuing up onwards. So thank you very much.